But you're all picturing me wearing a tank top right now. Like a muscle shirt. It's not really my jam, Brian. No. I don't go with the muscle shirts. Not that doesn't mean I don't have muscles. Okay, it's just, all right, here we go. Now that I have your attention again. Let's take a look at this one. This one looks awful, right? Certainly does. Let's go to the toolbox. Hey, don't you think we should start with the toolbox? Yep, me too. Write everything in terms of sine or cosine. I only have sine terms in this problem, so I don't need to worry about that. Manipulate and substitute Pythagorean identities in for squared terms. No squared terms. So I'm not going to do that. Factor out a common term and or the difference of squares. There's no squares, there's no factoring. If you're like, yeah, but there's a minus here. We don't factor with fractions like this. We just don't. If there's a fraction like this in or a rational expression in the problem, we're not going to factor. Okay? So that means we can get rid of this. That means we can get rid of this. What about finding a common denominator and combining fractions? They don't have a common denominator, but simplifying this problem might mean combining these two fractions together. And now you might realize why we did what we did on the opener. Okay? Do you see the similarity between the format here and what we're looking at now? Right? It's not x's, it's sine x's. It's not 2's, it's 1's, but very similar. Right? So, yeah, we may want to do that. What about multiplying a binomial and a fraction by its conjugate to produce the difference of squares? I'll be honest, this makes a lot of sense for this problem. Okay? But what's kind of funny is that we're going to be doing that by doing this. You'll see what I mean in a second. Decomposing a fraction that looks like an inverted triangle. This is actually the opposite of that. Right? This triangle looks like this. So not inverted. Inverted means upside down. Right? So we don't decompose, y'all listening? We don't decompose fractions from the denominator. We only decompose fractions from the numerator. Okay? So, not doing that. So the only thing, well, what makes the most sense is combining by finding a common denominator. So let's do that. Let's color code this. I'm going to multiply this times the bottom. And do you notice that by doing so, conjugates? Yeah. Okay. Then I'm going to take this and multiply it over here. So what do we get? On the bottom, now let's do this, because Nicholas pointed this out to us earlier. These are conjugates. When you multiply conjugates, you produce the difference of squares. You've heard me say that many times. Never in person, because we're always through a computer screen, but I've said it many times. When you multiply conjugates, you produce the difference of squares. So square that, and take the difference. And then when I write that, if you've watched all these videos, if you've kept up, you're like, 1 minus sine squared. Think I see where this is headed? Maybe. On the top we have 1 minus sine x. Minus. Now I'm going to get the same denominator over here when I multiply those conjugates, because that's the common denominator that we're trying to find. And then on the top I have 1 plus sine x. Now, I found the common denominator, but I didn't actually combine the fractions, and this says, find a common denominator and combine fractions, okay? So now I'm going to actually put them together. This is going to say 1 minus sine squared x. And on the top, when I combine this, we saw this in the opener, we are subtracting this. So we have to make sure that we're taking the opposite of both of those terms. And I'm going to stretch this thing out here a little bit. So we have 1 minus sine x minus 1 minus sine x. Stay with me. Oops, oops, there we go. Now we clean this up. Look in the top. 1 minus 1, common terms, they cancel, they're opposites. But this is a negative sine x and a negative sine x. So I have two negative sine x's, otherwise known as negative 2 sine x, right? Those are common terms. We've said before, I'm on record as saying this many times, we treat the trigonometric package as one piece, as if it's a variable. Even though it's a string of letters, it's one piece. So if I have negative and a negative, that's two negatives, that's negative 2 sine x. So now we're here. Now we can go back, so we've combined the fractions. Tool successfully used. Now when again, I know I keep saying this, but I mean there has to be some awareness at this point. This is the, ninth example that we've done. There, 10th if you include the opener. 11th maybe? You have to have some awareness for this. You have to have a radar that's like, oh yeah, squared term and a 1. There's something I can do with that. We've done it a handful of times already. So you go off into the, what am I going to write here? The margin. We go off into the margin and we figure out how we're going to get a statement that says 1 minus sine squared x. What do I do to this to have it say 1 minus sine squared x? Well, if I wanted to say 1 minus sine squared x, I would just subtract it from that side. And I would get a statement that says cosine squared x equals 1 minus sine squared x. So there's the manipulation. I didn't point it out, I didn't go back to the toolbox, but that's what we're doing. Manipulating and substituting for a squared term. That's what I said, you just have to have that radar that's going off in your head now. So this can replace that statement. So we're going to do that, because I have that statement right, oops, I always miss it, right there. Negative 2 sine x over cosine squared x. Now, if you stopped here, I wouldn't blame you, okay? But if you wanted to get super crazy with it, if cosine ever shows up in a fraction with the where it's in the denominator, I can replace that with a secant that's not in the denominator. So I can take cosine out of the denominator of a fraction and replace it with a secant that's not. So I'm not replacing this with secant, right? Gosh, every single time I miss it. But I could take this out, and when I take it out, call it secant squared. So this would be a statement that says negative 2 sine x secant squared x. That's taking it up a notch a little bit. Okay, I can't cancel this with that, but if I want to get that out of the denominator, I can call it secant. But I would be okay if you left that, just for the record. Okay, so what did we do? Combined fractions by finding a common denominator, cleaned it up, manipulated and substituted for that. Tools that we've been using.